Welcome to the channel. So in today's video I want to discuss about bagging, which is an ensemble learning method, and this algorithm works by using multiple base models and uses a subset of the training dataset to train many individual models, then takes the aggregate on those individual models. So let's get started. I will implement it using Scikit-Learn. So as usual I need some libraries. Okay, so import pandas spd matplotlib. Then from Scikit-Learn sklearn model selection import train test split. Then from sklearn ensemble import bagging classifier. Finally from sklearn import matrix. Sorry, typing mistake. Okay, so now it's time to load the dataset. So I have to use a dataset that is called class identification. It's a CSV file, so I want to load it using pandas. So class identification.csv. Okay, _head. So this is the dataset and the first 5 rows. So the last one is the target, which is type of class, and before that we can see some symbols for different chemical components. So this is sodium, magnesium, aluminum, silicon, potassium, calcium, barium maybe, and iron. So these are different materials that are used for preparing class, I think. So let's now check the shape. Okay, so it has 214 samples and 10 columns. 9 of them are features. Last one is our target column. Let's check if there is any null values in our dataset. No, all are zeros, so there is no null values. Let's also check the unique types of class. Okay, so we have 1, 2, 3. Surprisingly, there is no 4, 5, 6, 7. It's a weird situation. Let's also check the value counts for these classes. Okay, so we can see 1:70 times 276, 29, 17, 39. So this one is not present in large number. Okay, So now let's separate our features and classes. So df.𝐂𝐥𝐚𝐬𝐬𝐢𝐟𝐢𝐞𝐫, just drop in the last column, and here only selecting the last column. Then we need to split the dataset into train and test. So xtrain, xtest, 𝐂𝐥𝐚𝐬𝐬𝐢𝐟𝐢𝐞𝐫. Train test is split. Random state for 2. Then we have to check the length of our sets. So xtrain, xtest, 𝐂𝐥𝐚𝐬𝐬𝐢𝐟𝐢𝐞𝐫. Okay, so we have 170 on samples in our train set and 43 samples in our test set, and in total we have 214. Okay, so now we can apply our classifier. So apply bagging classifier. Let's call it CLF. Bagging classifier set OB score is equal to true, random state for 2. Then we feed our training data. Xtrain, 𝐂𝐥𝐚𝐬𝐬𝐢𝐟𝐢𝐞𝐫. After that also let's check the out of bag score. Okay, so we have fitted our training data on our classifier, and the out of bag score is 67%, 67.84%. So this is the accuracy on the out of bag samples, which the individual models or base models cannot see when they are fed with different types of subsets from our training dataset. Okay, so let's now train accuracy on the train set. CLF dot score. And also let's check the accuracy on the test set. Okay, so we have an accuracy of more than 98% on the train set, and an accuracy on the test set is 83.72%. Okay, the problem here is that train accuracy is very high compared to the test accuracy. So currently our model is not robust, meaning that it's not performing on unseen dataset as well as it is on the train set, which contains the data on which the model is trained. So let's check it out. So it has an estimator. By default it is none, and okay, so if none, then it uses decision tree. So I suppose it uses all the default values of the parameters that decision tree has in Scikit-Learn. So let's change it to see if we can make it more robust. So let's import decision tree. Okay, then just copy these 3 lines, change the variable name, and here estimator decision tree classifier. So if I leave it like this with all the default parameters, I think we'll get the same values that we got here. So let's run it first. Yes, so I think this is score and this score is same. But now let's change one parameter. So there is a max depth parameter. I think by default, we can also actually look at this. So this is before adjusting this parameter. We have already run it. So yes, so we get the same values like this one. But now let's adjust the max depth parameter, and I think by default it is none, but I want to use 5. Okay, so now we have a different out of bag score. It reduced a little bit from 67.83%. It became 65.498% or 497%. So it reduced by 2%, I guess. But what about our accuracy? But we can see a change on our accuracy after adjusting this parameter. So now our model is more robust because the training accuracy is not as high as this one, and it is 88%. And accuracy on the test set also increased from 83 to 86. So we got a more robust outcome. So I think this is a better option. Now let's plot confusion matrix. So I print CLF underscore predict X test. Okay, so now test dot plot map size 15. Then we need to add the levels. Prediction and font size 15. Font red bold. So this will be Y level and shall be title. Ground truth and confusion matrix. This will be x, and then y-ticks. So this is how our confusion matrix looks. So we have 6 classes, but there is no 4. I don't know why there is no 4. 1, 2, 3, 5, 6, 7. Okay, so we got few wrong predictions in class 2. Class 3 is not a good outcome. We have 1 correct and 2 wrong predictions, and some 1 wrong prediction in class 5. Others look correct. Okay, let's check F1 score. Okay, so our F1 score says 85%, and finally we can print classification report. So matrix dot. Okay, so we will not get good values for class 3 because the number of samples is very less, only 3, and we got 2 wrong. So one of class 3 is predicted as 1, another is predicted as 2, and only one is predicted as 3. So we have 4 fellows for class 3, but others look more or less okay, and these are all correct. Okay, so that's how we can implement bagging classifier, a supervised machine learning algorithm, and an ensemble learning technique using Scikit-Learn. And I used it on this dataset, which doesn't have a lot of samples. So I think that's the end of this video.